f of x and y is equal to x squared plus y squared. What's f of r and theta? Take some time to think about this. It'll make it more fun to compare your answers later. Before I give you the solution, I want to show you what some of my friends said. I gave this problem to 8 college STEM majors, and they all agreed on 2 different answers.
Why?
Okay.
I would assume that I'm replacing these, so then I would just put this where that is, put this where this is.
You can just change it x to r and y to theta.
R squared plus theta squared.
Wouldn't it just be r squared plus theta squared?
R squared plus theta squared.
Good as you're getting.
Okay, I'm just gonna draw out my axes. X and Y. I can also have my R, my theta.
You're trying to do it from Cartesian to polar, in which case it would be r cosine theta plus r sine theta.
So we know x equals that and y equals that, so we're just squaring them.
So I would say r squared.
R squared? Is that right?
Yeah, let me write that.
Okay. We just get r squared.
So what's the reason for this split? Half of them got the answer r squared plus theta squared, and the other half got r squared. Something interesting shows up when you ask them their majors. While our r squared plus theta squared crew came from pretty diverse backgrounds,
My major is biology.
Computer science.
Biology.
Mathematics education.
our r squared people had one thing in common.
I'm a physics major.
I'm a physics major.
My major is applied physics.
I'm a physics major.
This problem seems to have some weird sorting power to identify physicists. Why? This problem is something we'd call a shibboleth, which is a custom, tradition, or speech pattern that can be used to distinguish one group of people from another. For example, if I asked you what's the answer to life, the universe, and everything, and you say 42, I know you're a massive nerd. Or if this is funny to you, I know you were probably a band kid in high school. Or, as an example for the normal people watching this, whether you call it soccer or football could tell me where you're from. Basically, a shibboleth notices differences between groups of people in order to identify which group you're from. This problem is known as Corinne's shibboleth, which is used to differentiate between mathematicians and physicists. Historically, math people will give the answer r squared plus theta squared, literally replacing the variables that are being plugged into the function f.
X and Y are 2 inputs. And then in the second function, R and theta are 2 inputs. I just squared those so it'll be equal to the function above.
And as we saw with my friends, this approach is super common among non-math majors as well.
X and y are just the placeholders, so regardless of what you do, you can just change it x to r and y to theta.
From the math perspective, the choice in variables doesn't have any real meaning. They're just dummy variables that can be switched out for one another.
Usually I think of it just as a variable, so it could be anything, right? I don't know.
But if you ask a physics person, those variables are not just interchangeable.
If you actually do a problem and you say r is your x coordinate, theta is your y coordinate, and Cartesian coordinates, you should actually be crucified.
Physicists tend to give the symbols x, y, r, and theta physical meaning, seeing them as actual location coordinates.
I mean, x and y, I think x, y, z, Cartesian, kind of your cube-based coordinate system, and then r theta, I think circles.
Like x, y, r, and theta, they're kind of like defined variables in a way.
X and y, and then r and theta.
They don't see this problem as just substituting one letter for another. Instead, they see it as a transition from Cartesian to polar coordinates.
I see x squared plus y squared. I immediately think of circle. It's kind of the formula for a circle in polar coordinates. So if we're kind of converting, I would say at x squared plus y squared is equal to r squared.
Clearly, there's a difference between how physics and non-physics people think about equations like this one. But why physics? You may have had a high school physics teacher say to you that math is the language of physics, maybe while trying to justify the trigonometry-induced torture that they were putting you through. But it's true. Physicists tend to use math as a tool to describe the physical world. But math and physics math are not the same thing. They're kind of like two different dialects of the same language. Just like the word football could make two different people picture two different sports, the same mathematical sentence or equation could mean two very different things to two different groups of people. When physicists look at an equation, they don't just read the words of that mathematical sentence. They assign meaning to those variables and use them to tell a story. For a more physicsy example, consider the equation blank equals blank plus blank. Most people would look at this equation and think, oh, that's an addition problem. But for a physicist, the variables involved are what tell the story. For example, if we wrote x final equals x initial plus v times t, this equation could tell the story of a base plus a change, like an initial position, some velocity that's changing that position over a certain amount of time leads to movement that gives you a final position. But plug in different variables and we're not talking about a base plus change anymore. Let's say we said mass total is equal to m1 plus m2. That could be interpreted as parts of a whole. You're adding one mass to another mass to get some total mass. In physics, variables aren't just alphabet soup that you pour into a calculator. A simple equation could have a totally different meaning behind it, just based on what variables are involved. The context matters. And for students coming into a physics course from a normal math background, this is weird. Because in physics, you're not just doing math. As Reddish and Kuo put it in their 2015 paper, physicists filter equations through the physics, interpreting the math as a story, not just rote manipulation of variables. So you might still be wondering, who is correct? That's the thing. Both answers are correct. It just depends on your context. Choosing one correct answer is like debating whether soccer or football is the correct name for the sport. Understanding the nuances of how students of different backgrounds use math to communicate can help us bridge gaps between physics and other disciplines. Because a lot of the time, students struggling with physics problems isn't a skill issue, it's a communication issue. A difference in how these students use the language of math.